as you copy what you are copying, I need you to pay attention. Good morning, Nigerian students. Yeah. I know you people are having MME test today, is it true? No. Okay, is this week but not today? Alright, so please, I believe we've done oxidation and reduction when I told you about when I do the box. You still remember? So, but we'll do small recap before we then get into balancing of redox reaction in acidic and basic liquid. Now watch. Please watch, you pay attention. Any element you can write. Any elements on its own has an oxidation number. Oxidation number of what? Of 0. Any element you see, hydrogen, helium, lithium, helium, once you see it standing on its own, it has an oxidation number of 0. Are you there? Which means that if I come here, look at what I have on this board. This thing is zinc. This thing is zinc. What's the oxidation number of zinc here? 0. What about this? Eh? Now, the oxidation number of any ion, be it hydrogen ion, any element or any ion is equal to the charge. The charge it's carrying is equal to the charge. So, since this is having minus, that means the oxidation number of this Br3 minus is simply what? -1. And that gives it to you. Are you understanding it? So, any ion, the oxidation number is the charge. So in that case, the oxidation number of this is what? It's making sense. The oxidation number of this is what? Because it's carrying. So the oxidation number of, for example, H is what? 0. Alright. And I believe you know what oxidation is. You are right. Redox reaction. Redox reaction. The word redox is called from reduction and oxidation. Redox reaction. The word redox is called from reduction and oxidation. Oxidation. The word redox is called from reduction and oxidation. Full stop. Oxidation is simply the loss of electrons. Oxidation is simply the loss of electrons. It's simply the loss of electrons and gain in oxidation number. Oxidation is simply the loss of electron and gain in oxidation number. Oxidation number. This is what oxidation is all about. Are you getting that? We say that metals undergo oxidation. We say that metals undergo oxidation. This is because metals undergo ionic bonding, which involves, this is because metals undergo ionic bonding, which involves the transfer of electrons from metals to non-metals. electrons from metals to non-metals. So whenever you lose electron, you are said to be a metal. Do you know that you can say that metals are men, while women are non-metals? Do you agree? No. Should I prove it to you? Should I prove it to you? Yes. Alright. Alright. When a metal and non-metal, for example, we know that magnesium is a metal. When a metal, we know that sodium. Should we have told you before that anything that carries ion on the periodic table is a metal? Have I told you before? Yes. Anything that ends with ion on the periodic table is a metal. Yes. So when metals, for example, if a metal combined with non-metal, which is oxygen, if sodium combined with chlorine that you know, what do you call it? Sodium. Have you ever heard of sodium chlorine before? There's nothing like sodium chlorine, should it? So anytime metal and non-metal combine, the non-metal will lose its last name and take up IDE. So when magnesium combines with oxygen, what happens? It will lose its last name and take up what? It will now be magnesium oxide, sodium chloride, calcium sulfide. And now what there now? Yes, that is the first reason why I said that metal is man, non-metal woman. Now the second reason is this. We know that metal, for example, sodium has 281. Do you agree? That means the share will be such that it will have 2 here. 1, 2, 3, 4, 5, 6, 7, 8. Then the last share we have what? 1. It's easy for sodium to lose this one that you get 7. Notice so? Yeah. That makes it a metal when you lose. Why, for example, chlorine now? I want to clean this. Chlorine on the other side is number 17, which means it's 287. Yeah. So it will be 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7. It's easy for chlorine to gain 1 than to lose 7. Now, when this one loses this one, when it loses this one will leave. Let me use this to do it. If you lose this one, it will go here and come here. Now, when it enters here, everywhere here is positively charged. That is why metals normally form something we call metallic bonding as well, a bond of positivity. Yes, the plus ions. Now, when you lose this electron, we are taking this electron now to the ring. There's something called valency. Human beings call it a ring. Yes. So when you lose this thing, this is the power of their bond. So what is given to it? Okay, so see, let's check something. Let's just check something now. For people that say they don't understand, please pay attention now. Watch. I can clean this, right? Yes. But watch. I need you to follow. The compound I have. I'm giving you that one as your classwork. You must do that one. But I want to make use of this compound. Let me say I have this compound PB. PB is what? Did I ask you? Will I allow everybody to answer me? Oh yeah, this one, what compound is this? It's not scrotum. Hey! Zachariah was a man. Jesus, open our mouth. A situation whereby they did not give me 2 compounds or 2 elements on the product side. Now I have just 1. How do I go about this? You know one good thing about this thing? Do you know that everything, see how we are filling the board? Do you know that all these things we are filling the board, this is just one question you will see in your exam, just one. That means that if you are not efficient enough to know that these are things. If you notice as I'm solving, I'm picking out tricks I'm showing you. The only time you will master or get to know that such tricks exist is when you've solved it over and over. It becomes second nature that instead of doing this, you can just pick this one out, pick this one out. So that is why it's important that you know this thing, because it's inside the exam hall that you'll be doing this and it's just one question. You need to be very fast. So if I have this, and they are asking me which one is the oxidation reaction, which one is the redox reaction, what is the answer, the product, what should I have as the product? For me to solve this, you can see that these two, this is a compound, this one is what? An element. These two reacted and it's giving me just one. Are you understanding it? It's giving me just one product. Any question on that? Let's see. And it's giving me just one product. That means that this is as good as being equal to iron, and this one as well is also equal to what? And what are you now? So this lead oxide is also equal to this, the iron, and this lead is also equal to this lead ion. Are you noticing it? So for that reason, what I'm going to ask myself is, when you are an element, your oxidation number is what? Then you are moving to this and you are having plus 2. Now, this is a compound. This compound, I told you for reduction reaction, or anywhere you see oxygen at the left hand side, that before you can balance or find the charge that these two have, you need to balance the number of atoms. That's what I told you. Make sure you always balance the number of atoms. And for you to balance the number of atoms is to introduce water, H2O. So I'll ask myself, how many oxygen do I have here? So I have 2H2O. So that the owner is 2. Then I can see that the minute I introduce this, I've introduced hydrogen. So I can now do 2 times 2 is what? 4. So I will come to the left hand side and introduce 4H plus ion. Just like that. Just like that. So before you can balance any redox reaction in acidic medium, you will notice that there is always oxygen to the left. And before you can start thinking about balancing the charge, if you forget yourself and start balancing charge, or you need to first balance the number of atoms. So if I'm through with balancing the atoms now, I can see that lead here is just 1. Here is just 1. Oxygen here is 2. Shebly? Yes. Hydrogen here is 4. So it's balanced. This is now when I want to say, let me check the number of charge. So that I can now see that it has plus 4 here. And this one has what? Plus 2. And remember I told you, I advised you to always put electron to the what? Left hand side, JB. Well, let's take it that side is not telling you the right thing. Now I want to try my own way. We'll put electron here. How many electrons can you put here and you will get plus 4? Is it even possible? Can you do plus, how many plus getting electron? Because the minute anything electron you're adding here is negative now, it can never come out to give you what you need here. So it's here I will add something so that I can get this. So in summary, I said you don't need to think about it. Just know that for reduction half reaction, always add electron to the left hand side. While for oxidation half reaction, always add electron to the right hand side. So I will now do, if I come here and see, notice here, notice that I have plus 4 here. Shebi, if I add 4 electrons here, this trick does not work here because this side is plus already. You remember when I told you that once you see that your charge, the charge you have here is plus 4H, and what you are seeing here is like minus 1. That what you just need to do is to come and do plus 4 electrons. Do you remember when I said that? That is if, for example, I have 3E balancing up. So that when I add this 4 now, it will now be 3 minus 4, which will give me what? So please, in this case, you need to play with your brain very well. So for me to get this side to be plus 2, what do I need to do? So I'll add plus 2e here. So that this will now be 4 minus 2. Anything electron is negative. If you say 2 electron, it means minus 2. If you say 5 electron, it means minus 5. So this side is now balanced. The charge here is now balanced. It's not the same with this because this is now 2 total. This is now 2 total. Balance. Do you understand this one? Any confusion? Let's go to this one now. And we know that this one is called the reduction half reaction, Shebi. It's an oxidation half reaction. Now let's go to this one now. This is 0. This is plus 2. What will I do to see that I have the same number of charge here? If I say let me add minus 2 here, this will be plus 2, this one will be minus 2. If we are, so always add electron to the right hand side for oxidation reaction. So I will now say plus what will I add? So that plus 2 plus minus 2 will give me what? 0. Shall we see it? So we can now say that our oxidation half reaction is balanced. The same number of lead, the same number of charge. So the minute we finish this, the next thing we now need to do is to see that these two half reactions are balanced. They are the same. They have the same number of charge. The minute you balance oxidation half reaction and you balance reduction half reaction, the next thing is to see that the two have the same number of charge. And for us to do that, I said simply do what? Cross multiply, Shebi. Not be so. Forget what you are saying first. Simply do what? Cross multiply. But here we can see that the number of charge here and the number of charge here is already the same. I have 2 now. Not be so. And I have 2. So even if I do cross multiplication, I'll still get the same thing. So there's no need adding or cross multiplying because our goal cross multiplying is to see that we have the same number of electrons here. You understand now? So since, let me bring what I have on the right hand side. Since I have B plus, notice something, 2E minus plus 4H plus PbO2. Let this thing come this side. Then notice here, I have this, Shebi. Bb plus 2, then plus, Shebi, and our proposal. No, we're not proposal, we're not proposal. Then B plus 2 plus 2H2O. I watch. Why I put everything together so that my friend understand what I said earlier. Since I have 2E here, I will be looking for what is common. I have 2E here and I have 2E here. It's best to cancel it out. Okay? We must agree first. So, what's it come again? Huh? This, why did I put 2E here? I'm putting 2E here. Yeah. Why did I put 2E here? It's not this side, it's here.
At this other side.
Well, watch now. Watch. Let's remove that in one line. Should this plus 2?
It's plus 2E for that first one. But why
okay, you understand this one?
The second
wait now, wait. Me and you will have the same thing. Let's wait.
That's the same.
Watch. See now, see. Watch. Shebi, this thing you don't like, let's remove it. How many charge do we have here now? This side, 4. Let me just write it, plus 4. How many charge do we have here? But we want it to be balanced. We want the charge here and the charge here. Okay, you understand it? Okay. So I will now add plus 2E minus. Now if I have that plus 2E minus, I brought everything down. You said that you agree that I can cancel this, Jimmy? I can remove this, and I can remove this. So if I remove it now, let's say I cancel it out. Cancel this out. So what I'm bringing down now is Pb plus 4H plus Shebi. That is lead oxide. 2 plus 2N. Plus 2H2. Well, let's check if we are correct. How many leads do I have on the left hand side? 1 and 2. Shebi? Let me just analyze. Let's analyze. I have lead. I have hydrogen. I have oxygen. Then I have lead. I have hydrogen. And I have oxygen. So we have 2 of these here. How many do I have here? 2, Shebi? I have 2. How many hydrogens do I have on the left hand side? 4. Okay, you are the one telling me. Okay. How many hydrogens do I have beside? 1. Oxygen, how many do I have? 2. Should be this one now. How many oxygens do I have here? 2. That is because of these 2, Shebi. These 2 belongs to each 2. So I have just 2. So the number of atoms on the right hand side and left hand side is the same. Do you agree? We are here. It's alright. What? So first thing, the key thing is to make sure that number of atoms is balanced first. When you separate the reduction and the oxidation reaction, balance the number of atoms first before balancing the number of charge. And for you to balance the number of charge in reduction reaction, you have to balance the number of oxygen. Then after it now, the 2 reactions, balance the number of charge in the 2 reactions. And the only way you can do that is to see that the electrons, if you have 2 in the oxidation and have 3 in the reduction, you use this one, multiply this one, use this one, multiply this one. Just like when you did substitution reaction, you still remember that time now, equation is substitution reaction. That time you did substitution equation and the rest. And you do substituting this one, other things. Now watch. Let's check for the number of charge now. I have plus. You know that this is the same as this times this. So I have charge to be what? 4. What about this side?
4.
So charge is what? 4. So this thing is balanced. Are you aware? It's balanced.
Yes.
So it's very simple. It's very simple. Once you master the trick, and the trick is simply balance atom first. Balance atom first. Look at the atom, see that it's equal on the left and the right hand side. If you come to the reduction half reaction, you notice that there's always oxygen there. Use water to balance it on the right hand side. The minute you introduce water, you can introduce hydrogen. Balance the hydrogen on the right hand side with H plus on the left hand side. If you finish it, balance the charge on the oxidation reaction, balance the charge on the reduction reaction. The minute you finish that, balance the charge on the 2. You cancel out. You are good to go. You now bring it together. So if I check that now, watch. If I check that now, I can see that this thing is totally balanced. Now, there is a case where they'll ask you, balance this in basic medium. Shebi, you know that what we are doing here is just acidic medium, right? Shebi, if you go through your textbook, you will see that there is so much story. There is so much story there when it has to do with balancing in basic medium. They will tell you, put OH minus left side, put H2O right hand side. Shebi, now what did I teach you? Please, I'm telling you now that for you to balance in basic medium, first of all, balance in acidic medium. The minute you finish your acidic medium, you get to this point where it is equal. Eh? Can you hear me? Yes. You now add OH. So you then do plus OH minus. Then come here and do plus OH minus. You will see how we balance that. But I want you to get it now. If they say acidic medium, the minute you add the H plus, do everything we've done so far. Get to the point where the atom and the charge get to look, or should I say, the atom and the charge is the same. You now see that it's looking the same. You don't need to do any other thing. You stop here. But if you are asked to balance in basic medium, once you get to that point where everything is the same, come and add OH to the water you have here. Add OH to the H plus you have here. Are you there? If I do that, I will see that positive gets attracted by negative. No be so. So if I have H plus and I have OH minus, these two will attract each other. This will attract this, so that it becomes H2. And then I have my O. Are you there? It will turn into water. Do you still remember when you did acid base? You can hear it again? pH.
That would be
if you don't understand, wait a minute.
Why do you write it in types?
Okay, this one.
Yes.
And this one. Let's check now. Ngwasi. These two. They gave me one product. That is this ion. And in some cases, they'll just give you and tell you that it's giving just one product. So if that is the case, this one is equal to this. The second one, everything here is equal to this. So when we bring our left-hand side, then we pull everything on the right hand side. Put everything on the right hand side. Maybe you know that this one was cancelled out. No. We are bringing everything on the right hand side now. Well, first of all, don't worry, you ask your question. Well, first of all, bring that one we have on the left hand side, what we have on the right hand side now. So if you check it, we are having this now. PB, let's do cross 2. Let's do cross 2. Then we have A2. Ask your question.
But we're supposed to write it since that reaction, this reaction is the same reaction that is connected to two.
We're supposed to write it only once, how?
Like the same.
It's not a simple reaction. Have you heard of combination reaction before?
No.
Also called substitution reaction. Such that if you have A plus B, it will give you AB. Shebi? But in this case, what you are having is not even AB, but the ion. And you're not telling me that I should combine what happened in oxidation and what happened in reduction.
Just try to do one. You're not combining it.
You are doing magic. You cannot have it only one. You are doing magic. Do you know when I say you are doing magic? Watch now. If I happen to do this now, PB, that is 2PB plus 4. I'm no longer following the pattern. This reaction, I'm no longer following the pattern because everything here happened at oxidation reaction. Everything here is happening at a reduction reaction. This is oxidation, this is reduction. What you do is the minute you balance these two, everything is the same. Carry everything on the right hand side to the same side, which is what I've even drawn for you. Practically, you're seeing. I'll carry everything here, this way. So, at this point, we are trying to now take it to basic medium. Can I clean that side? Can I clean the left hand side of the board? Yes. But wait, is this thing simple?
No, it's not simple. What is it?
Give me the right method. I will show you shortcuts. That's why I'm here. But what I'm asking you now is, this one so far so good. Even if it's not simple, have you gotten to the point where you are understanding how it works?
Yeah, yes, I understand.
Oh yeah, let me clean. Somebody said they play. So I've been able to balance this. And I told you that if they say basic medium, If they say balance this, they give you this as a basic medium, first balance in acidic medium. Then you now add OH. So that I have PB plus 4H plus PbO2 PB2 plus, that is left 2 plus. Some people will go inside the exam hall, they will see this iron that day. Let's say they have aluminium, this aluminium, and this aluminium maybe they come and say that this now is having something like 3 plus. They now say maybe they use X here. They ask you which element is this. They have this, they now put X plus. They ask you which element is this. Some people will write aluminium. Because it's only aluminium that you know that is always carrying AL plus 3. Chevy? Awesome, yes. Please, so what will determine what you have is simply what you have on this equation. So I have PB, guys, let 2 plus let 2 plus 2H 2O. There is a question I posted one time on the group. There's a question I posted one time, sometime on the group. I said, like, if an element, I've forgotten how I put that question, but I know if an element has 3d5, if the orbital of an element ends with 3d5, that what